Hey guys, this is Chandler Vincent with weldermade.com. Today we're here to learn a little bit about welding stainless. Go ahead and look at your blueprint in the bottom right hand corner and check that part number. We are working on the month of February's stainless steel subscription. The part number is in the bottom corner. Just make sure that matches and follow along. So the first thing I always do when I'm looking at these blueprints is I look at all the different views and I try to get a good understanding of the geometry of the blueprint to where I can understand what pieces go where. One of the most important things is looking in that top right hand corner on all of those little bubbles that have the numbers 1 through looks like 9 in this case. That gives each part a number and it tells you how many of those parts exist. So right next to those bubbles you're going to have a 1x or 2x. If it's a 2x, that means that there is 2 similar parts to that number. So go ahead, and I like to count those bubbles, make sure that I have the right quantity of parts, make sure I understand what parts go where. All right, once you understand your blueprint, go ahead and count your parts, make sure you have the right quantity and the right parts, and then we'll start the cleaning process. So I've got these 2 pieces that are number 5. They're 2 of the same, but notice that they are mirrored. We do that so each part has the dross facing towards the inside of the project. That way you guys can understand that these parts go on opposite sides of the project. So that also helps you in the cleaning process because you can go ahead and just take off all that dross with a rough flapper wheel, not worry about scratch marks because that's going to go on the inside of the project. So we've got our 2 number 5s. We've got our 2 number 4s that are mirrored. And then we have our 2 number 3s, our number 7, and our number 6. And then we have our number 8. And just a quick tip, the reason why every single stainless project has this rectangle piece is because we want to give you guys the opportunity to see the inside of the project, to look at your penetration, and also purge. So I like to put a purge line in this hole, tape it up, and that allows you to fill the inside of the project with argon and get a nice clean purge. So every time you see a stainless project, you have this rectangle. That's why we put it there. And we've got our 2 base plates. We got the bigger piece, it's number 1, and then number 2. Looks like you guys should have 12 pieces for this project. I'm gonna go ahead and count mine. And 12. All right, I got everything I need. I'm gonna go ahead and start the cleaning process. When cleaning these parts, you can use multiple things to clean the dross off. Just make sure you get that dross off. I'm gonna use a flapper wheel on a die grinder. You can use a flapper wheel on a regular grinder. You can use a Dremel. You can use a hand file, whatever you prefer. Just don't worry too much about scratching that side because again, it's gonna be facing the inside of the project. So with that said, all my parts are clean. I'm going to go ahead and rub them down with acetone and get rid of any surface oils or contaminants. This is kind of a long, tedious process, so we will fast forward the video for you. Make sure you wipe down the front and back because with this thin of sheet metal, you will be burning through and you want to be sucking in clean metal on the backside and not contamination. For this project, or all the projects, I like to use this product that we have called the Easy Tack. This is a product I designed and wanted to get to you guys really cheap, really affordable, and will help you guys tack up these projects. I know right now that a lot of you have had a hard time getting these projects tacked up in the first place because you are trying to hold three or four parts together while holding filler wire and a torch in one hand and use a foot pedal at the same time, and it makes it really hard. So the easy tack is this tool that I have made that's bent perfectly at a 90-degree angle that can be used for our other angles, and I'll explain that in a minute. So I like to put the parts in there, draw side facing down, and this is how this tool works here. You get these nice little rubber clamps, and you can make your corner joints, have hands free while you tack all your corners, while it holds it for you, hands free. And that is super helpful when you're working with filler wire and a torch, because it holds it while you tack your project together. This can also be used for fillet welds, just like that. And then if you are tacking something together that is not a 90-degree angle, which is pretty common in these projects, tack it together at a 90, pull it out, and then just bend it to the angle that you desire. You guys can make something a lot like this at home, and if you want to, go right ahead. I just wanted to make it super accessible and affordable to those that would just like to get one and get going and start learning. So when you're tacking these projects up, always start with parts that are on the same plane. Okay, here we go. Okay, as you guys can see, those are all tacked together nice and straight. Notice how clean those tacks are. It is very important to not start off with oxidization on the get-go with your tacks. So a lot of people will have these nasty, dirty gray tacks all over their project, and every time you're welding and you run over a tack, you're running right into that oxidization, and your weld pool becomes turbulent, and that's not good. So remember, keep those tacks nice and clean, a quick little burst, leave the shielding gas there until the puddle is solidified, and you'll be good to go. So now that that piece is made, I'm going to be making that same piece, just the opposite direction. Okay. Now we have those two parts. We will transfer over to the easy tack and go from there. Those little fusion tacks work perfect with parts like these that have nice sharp corners and nice straight edges. So now I'm taking my other set of three parts 3, 4, and 5, and I'm tacking them to the other side of part number 9, making sure that these joints are as perfect as I can get them. Okay, the reason why I wanted to tack part number 7 on top of the structure is because it's going to keep these two plates parallel. And that'll help me when I go to tack on part 6 and 8. So we're just going to do a quick little fusion tack. Okay, so that's ready to go on that assembly. I'm going to go ahead and tack parts 1 and 2, which are 2 base plates. I want you guys to pay attention to those corners. See how we have rounded corners on the outside corners? That is to protect you when handling these projects. We don't like to have sharp corners when the project is finished. So make sure the parts with the sharp corners are the ones you're tacking together in the weld joint, leaving those nice round corners to the outside of the project. Just a quick little tack. You can see that that tack is nice and shiny and silver. That means that we didn't have any oxidization and we could weld right over that, no problems. That's the way I want your guys' tacks to look. Line that corner up and do it again. That is a more oxidized tack. See how it's blue? That has a little layer of oxidization on it compared to this tack that's perfectly silver. Okay, so if you guys have these funny angles on these projects that look intimidating. You don't need to grab an angle finder. You don't need to set that to a specific angle and try to figure out the angle. Use these parts that I provide for you that are perfectly cut with that angle to match the angle that we desire. So instead of going and getting an angle finder tool or anything like that, we're going to use the project in front of us to perfectly line up that angle. So I'm going to go ahead and tack parts 8 and 6 onto our assembly. And if you brush your tacks right after you tack them, while the stainless is still warm, it cleans that oxidized layer off way easier than if you let it cool down. It's something that happens metallurgically. I cannot tell you why. It's a little tip that I have found within the years. If you have a bad tack that gets oxidized quick, hurry, grab your brush it off, and it'll polish off nice and clean. Now we're going to go ahead and tack it on to our base plate. Okay, I'm going to go ahead and push this down flush and do a quick little burst tack in those corners to get them to hold. So what we need to do is make sure we have tacks on all of your corners, and anything that combines multiple pieces, we want to put a tack. And what that does is allows the heat to transfer through each part evenly. You want to weld certain welds before others. If it's a really heat sensitive weld, say like this outside corner that has nothing but atmospheric pressure behind it, it is going to heat up faster than this weld here on the bottom where this fillet weld is, because it has something to absorb the heat out of the project, and it is a bigger part, which is going to take more heat to bring it up to temperature and make this project work with us and not against us. And so that is my biggest tip when welding the stainless project, is heat management. So we're going to start with these horizontal beads. Then we're going to do all of our verticals. Then we're going to tie those in with all of our upper corner joints. And then we're going to tie all of those in with our base weld all the way around our base plates. So today I'm not going to use a inside purge because some of you guys don't have the setup to do it. So I'm going to show you that it's possible without it, and that you can weld stainless without a purge. Most of the time you're going to have a purge on the inside. If you have the capabilities of doing it, you're going to find that your project won't get as hot as fast because you have the cool argon flowing on the inside, and you will find that it is easier to have a non-turbulent weld pool because you're not sucking in oxidization from the inside. So if you do not have a purge on the inside, you want to try not to penetrate into the inside, because you'll pull that oxide layer through the weld pool and your weld pool will become turbulent. So I'm going to be welding at lower amperages. I'm not going to be trying to get full penetration for the purpose of this video. In the next months, we will put a purge hose on the inside and teach you how to properly purge these projects. But for the month of February, we're going to get right to it. Guys, before you start these projects, it's very important to check your shielding gas pressure, your cup, and we do all of that with this simple trick. Get you a piece of scrap metal or a weld coupon. It's very, very nice to just do this little test. So if you have a little piece of stainless laying around, just grab your torch, have it nice and straight and square above your plate, and we're just going to make a little tack weld. And then we're going to let off the pedal, and we're going to let the gas sit there and flow. And if that tack at any time turns gray, blue, dark gray, or anything like that, that means that your shielding gas is turbulent. That means it's coming out, grabbing oxygen out of the atmosphere and putting it in your weld pool. And right off the bat, we're going to know that you need to fix your gas pressure, your gas cup setup, or your tungsten stick out. You can have your tungsten sticking out too far. So just do this quick little test and make sure that your gas pressure and your cup and everything is set up just right. Make sure you have a post flow and a pre-flow set on your machine, and make sure your gas settings are set properly, and we're ready to weld. Okay, now that I'm done welding, I'm gonna let that post flow sit there until that weld metal is nice and solidified. And not just solidified, cooled down. So it can be solidified but still be hot enough to oxidize. And why it's hot, I'm going to brush the end of this weld and the beginning of this weld, because I'm going to have to weld over that weld metal with future welds. So you're going to want to look at this weld you just welded and see the color of it. If it is dark gray, that means that you are having too much oxidization. There's something wrong with your shielding gas setup. So go back to the board, make sure your shielding gas is set up right, and also make sure that you are the right temperature and the right travel speed. So you can have a good setup with gas, but you can move too slow with not enough filler and make that stainless too hot, and then it's going to oxidize no matter what you do. I'm going to leave my cup there, let the material cool underneath that shielding. As you can see, we are having these nice consistent heat lines. The bead is nice and colorful and shiny. That means we have a good gas coverage and our travel speed is perfect. Okay, so now that those are welded, I'm going to do these outside corner joints. I'm going to clip my end so I don't start off with dirty filler wire. I'm going to progress up this corner joint. Okay, there's all of those welds. I'm going to go ahead and weld across all of these top joints so I can go switch my settings over to the bolts for this other side. I'm going to let this sit until it cools. And while it's warm, I'm going to hurry and brush the outsides of these corner joints. When you're getting to the end of these joints, your base plates that you're welding on are starting to get really hot, and so when you get to the end, start backing off your foot pedal if possible, and that'll make you weld at lower amperages and adjust for the temperature of the plate. Okay, that's all welded up now. So I'm going to bounce to this other side for a minute and let that cool off. Okay, so that corner welded up really nice. Okay, so now that my welder is on a pulse setting, let's talk about pulse for just a quick second. So on most of your welders, it's going to be adjusting the frequency, and that is how many pulses per second, and that's going to be referenced in hertz. And you're also going to have some sort of phrase. It changes from welder to welder. Different manufacturers have different terms, but in my welder, it references as background current. And so the background current is on the down pulse. So on the down pulse, you get to adjust how much percentage of your overall amperage it's running on the down pulse. So I'm clear down to a 20% background current, and I am a half a pulse per second. That is a very dramatic pulse, but what that does it gives me a burst of heat, and then it melts the weld metal, melts the filler wire, and then I can progress on my down pulse. And then when it pulses again, I add my filler wire, and that just keeps the overall temperature of the project down and my weld metal temperature down. Be careful to avoid lack of fusion when using a pulse mode. So that is how I use my pulser to my advantage. It can be used a very good tool because it helps with heat management. It helps with consistency. It kind of gives you a timer. I like to add filler wire on my up pulse and then progress forward on my down pulse. That is all that we have for you this month. If you got here through a QR code and you are a Welder Made subscriber, we appreciate you. We thank you for being here. I cannot wait to meet with you guys next month on the next project. Well, we will learn even more. See you next time.